Hello all. In this first part of the tutorial, we are going to create a terrain to use with the rest of the tutorial. With this, we're going to use the new Heightfield technology that was introduced in Houdini 16. So let's get going. To do this, we're just going to start with a Heightfield node, which will be a geometry node that will have a height field inside. So if we zoom out using G to zoom to the extent of our size, we can see the plane. So let's start adding some noise to this. That will be height field noise. We can simply connect the nodes, visualize it, and we have some noise. Okay, so let's pick a different, more aggressive noise. So I'm just going to get some simplex. And in our case, I actually want to make the terrain above the world 0. So I'm going to disable center noise. This will put it way above the world. So in that case, we can basically say in the future, if our water level would be, say, 100 meters, it would be above 0. Unless you prefer it to be at 0. I mean, it's up to personal preference in this case. Okay, so since this is just a simple noise, you want to actually add some more details to the terrain. So let's do that. And I'm also going to get rid of this Lomon. So we can just go press the D button while having the mouse over scene view. Go to guides and disable origin Lomon. Now that's gone. Okay, let's go with a feature mask. Heightfield mask by feature. So we're going to say connect that and select that. So that will select a lot of our terrain as a mask. But we don't want to select all of this. So we're actually going to shrink our mask until we have just the right amount of slopes. Let's get something like this. Maybe little, wait, no, the other side. So you want to have only the steep parts of the terrain. Okay, so because we actually don't want to have all these small areas masked, we need to build a small filter. And we can do that with a series of the same nodes. And in this case, we're going to use a Heightfield blur. Because a Heightfield blur node has a lot of different settings. And the first one we're going to use is shrink. So let's use that. Oh, that's not the one I meant. I meant mask blur, of course. Okay, there we go. So if we set it to shrink, yes, now we can actually filter out all the small areas. But we still want to keep the mask the same size as it was before. So we can actually just copy this node and set it to expand. And if we keep this value the same as the original value, the mask will remain more or less the same size. To make sure that whenever we change the value, the other one also changes, You're going to copy the and paste the relative reference. So now we can start changing the filter. But because we also don't want to deal with these squarish masks, I'm just going to add another blur, and this time we will put it either on box blur or on normal blur. So now we have a working filter. And I think I want to filter out about this much. Okay. So let's add a feature where this mask is positioned. And in our case, I want to add a terrace. So let's do that. Okay, so now it will just create a terrace here instead of using the mask. So to actually use the mask, we have to connect the other input as well. But right now, the minimum height and the maximum height are not actually at the height that we had the mask. So just make sure that these values are sufficiently high. This one is sufficiently low. There we go. So now we have our masks, our terracing done following the mask. So because we actually want it to make it look a little bit more natural, we're going to add some smoothing on the other side of these cliffs here. And there's multiple nodes that can do that. But so first we're going to look at the Heightfield slump for this. Slump. Okay. But as you can see, sort of tries to override the mask. And it's not actually adding a whole lot of dirt right now. So to make sure that actually it uses the entire terrain, we're going to add another mask. And in this case, we're just going to mask everything. So I'm just going to delete this key and this key, and that will basically generate a mask of the entire terrain. So now you can actually start to see the difference. To demonstrate, I'm going to add a clear. Pardon me. Okay, so now we can see the difference with and without the mask. So you can play these values a little bit. See how much dirt you want to add in the concave shapes. And just to demonstrate that the Heightfield slump does require a Heightfield, I'll try to clear it. But yeah, you see there's no difference at all. But when I mask it again, it adds all the slumping. So that's one way to do it. But the Heightfields also have a erosion node we're going to use now. So when you first visualize it, it will create this weird color shading. And that is because the range is not computed right now. So if we simply press this button, it will update the range. So the right end of the ramp meets with the top of the terrain, and the bottom maps with the bottom. Right now, you can still see that the mask is sort of baked into the colors. So to make sure that doesn't happen, we'll add a Heightfield mask clear. And now that's gone. Okay, so right now it's just colorizing, but not really doing any erosion yet. And that is because to do that, you need to move forward on the time frame. So if we just press right arrow key a couple of times, we can see that it starts to erode. And this works, but if you would at a later stage by accident hit like the arrow keys, it would start to recook the entire network that would be below here. And because we want this to be sort of semi-locked, you would like to avoid that. So you could build like a cache, but the option I want to present is using a time shift node. So we can get rid of this expression, which is just $f, by holding Control Shift and clicking. And now we can set this frame number to the amount of iterations that we want. Because the frame shift node basically makes sure that all the nodes above it are cooked at the frame that is specified here. So you can see now that this is a time sensitive node and this is not anymore. But if I would add a different node, Heightfield mask, something like this. Yeah, so you can see the clock. But the time shift stops that. You can also use middle mouse button click and see time dependent. Yes. And time dependent, no. Okay. So let's convert this to a height field, to a polygon mesh. So height fields convert height field. Okay, there we go. Actually, we do want to keep all the colors generated by the Heightfield erode, and that can simply be done by enabling bake point colors. This logic basically fetches the shader of the height field and bakes that into the point colors. And if you want to know how that actually gets processed, you can actually go inside. That will be outside of the scope of this tutorial, but just to quickly go over it, whenever you see one of these lock icons, this one doesn't have it, this one does. That basically means that the node is a Houdini digital asset and that it actually is a selection of more simpler nodes inside. So if you ever need to make a custom version of a node that has a lock, you can do it. Okay, so before we continue, let's actually increase the resolution of our mesh. So we're just going to reduce the grid spacing to 1. And because of the time shift, it actually doesn't automatically recook. So to make sure that it does, just going to press the reset simulation. You can already see that it takes much longer than before. Okay, there we go. So one other thing that I'm not really happy with is that the top of the terracing is really flat right now. So let's say we want to add some more noise to that. So add that just before here. That's one of the best features of Houdini is that you can add new features into your network at any point. So let's add another mask by feature. We're going to actually decrease the range. So we're just going to go between 0 and 30. Create a mask. Let's remove that keyframe and start to move these ones to the left. Okay, so now we can actually precisely mask all the areas that are really flat and blur it a little bit or not. Okay, so again, we want to filter out all these small areas first. So we're just going to copy paste all of this, and it should actually remake all the links to this node now. If you want to make sure that the links are correct, you can go to View and go to Dependency Links, Show for all nodes. So yeah, you can see that this node is referenced by this one and by this one, and also this one because of the mask, I assume. Okay, so these ones are also linked. Okay, so if I connect that there and go back here, yes, okay, so now the filter is a bit too strong. So let's make it a little bit less aggressive. Something like this. And let's add another noise node. Heightfield noise. Okay, so again, we want to actually only mask noise where the mask is. And right now, the noise is much too strong. So we actually need to reduce the scale quite a bit. So let's put the amplitude on, say, 30 and the element size of 250. Okay, so yeah. Now we get a more subtle noise that doesn't create like, well, it still creates a little bit of these bits. So maybe we need to be even lower. But at least now there is some roughness in these really flat areas. So if I reconnect that there, yeah, now you can actually see the difference. Just a little bit of extra noise. And you can add like many more of these adjustments to it. Basically, I think, yeah, just to show off all the Heightfield nodes, basically just press tab and go to terrain. These are all the options that you have. And I think that probably the Heightfield erode and the mask by feature are probably the most powerful of these in combination with the noise. Okay, so let's actually recompute the erosion again. So it actually includes our new noise there. Okay. Oh yeah, so it's only frame 13 right now. But if we go back to frame, the time shift, yes, there we go. Okay. There we go. Okay, so there is one more thing that I want to do before I cache this out. And that is actually adjust some of the attributes. If you made a mouse button click on the convert height field, you actually see a lot of these attributes. And most of these actually come out of the height field erode. And a lot of these will actually reuse later on in this tutorial. So First off, you can actually see that this flow_dir underscore x, flow_dir underscore y, and flow_dir underscore z or z are 3 float values. But instead, I think what we actually want is for it to be a vector. So let's build our own vector. I'm going to do this with a attribute wrangle. Combine flow vector. So I'm just going to say v at, which basically casts this attribute to a vector. Flow here equals set, which is a function that you can use to convert 3 float values into a vector or more, like or to a vector 2 or to a vector 4 if you want. So these are flow_dir underscore x, flow_dir underscore y, and flow_dir underscore z. I add the f before it, so I'm always sure that it is a float. Usually, if it's just defined like this, you can assume it is a float, and it will treat most attributes like it, except a couple, like position and color, and normal, and so on. These are all noted somewhere in the documentation, but just to be like exact, I usually prefer to always cast my binds to make sure that it is the exact type that I want it to. Okay, let's see if that worked. Okay, so yes, that should now work. So if I go to the geometry spreadsheet, scroll a bit to the right. Yeah, so we can now see that flow_dir 0, 1, 2, which is our vector, is the same as the flow_dir underscore x, y, z. And because we don't need those floats anymore, we can now use an attribute delete. And simply put flow_dir underscore asterisk. And now they should be gone. So now it's only the vector attribute that's remaining. Okay. So zoom out again. And just to demonstrate what we just made, I'm going to add a visualize node. And I'm going to add a marker. It's going to be a vector. And it's going to be flow_dir. I'm just going to copy paste that here as well. And there we go. Okay, so now it's a bit much. So let's increase the scale a little bit. But now if you start to zoom in on the terrain, you can actually see that these float directions actually follow the erosion that we generated. And you can use this kind of information to generate flow maps for the water meshes later. Say if you want to create a water mesh that has a flow map assigned to it, you can use that to fetch the data from. But there's also a lot of other attributes like cliffs, flow, mesa, which is also coming from the erosion node. And in the next tutorial, we're going to add some more terrain attributes as well. Okay, so let's create a cache. So I'm just going to create a cache, a file cache, which is just a default version. Like most people will probably create their own file cache system eventually. Okay, so right now, if you use a middle mouse button click on this label, this is where it will save it to. And I don't want it to be saved here. I want to save it next to my file, which is what $hip does. But because I have not saved my file yet, that's not where it goes. So let's save the file. Okay, just going to save that here. Terrain pipeline underscore Heightfield. Save that. And now it actually goes there. And you can also see this 13 here, which is coming from here. And that is this $F. And in this case, we don't want to actually have that in the file name because we don't want to save a different cache for every file, for every frame. So we're just going to save current frame. And now we do have an extra option, and that's down to personal preference. So right now it's actually saving this to terrain pipeline underscore Heightfield this point file cache 1, which is this node name. So let's put this as Heightfield. Okay. But personally, I prefer it without the hip name. So it would save it to here. And why I prefer this is because if I resave the file to a different name, it's still able to use the same cache. But if you want to maintain a versioning system of your caching, then you might opt for actually using a hip name in there. So that's again down to personal preference. Okay, so right now, if I load from disk, it will error out. It should error out. Okay, because it's still using my old caches, I guess. So if I save to disk, okay, there we go. So yeah, now it should match what I just had. Okay, great. Okay, that concludes the first part of this tutorial. Next, we're going to add some more terrain attributes, and we're going to get some more into coding, into vector wrangling, to be exact.